Hi, Jonah. How are you today?
Great, Junko. How are you?
All right. Well, this is the hot take I was looking forward to for a long time, actually, because um, this is a pretty big news. NVIDIA's investment in Intel, something neither of us, maybe you have, I had not thought about for a long time this would ever happen. So tell us, John, why this really matters to the semiconductor company, I mean, semiconductor industry.
Yeah, sure. So as we saw, NVIDIA was putting about $5 billion investment into Intel through a common stock purchase. So it was, this is substantial. It helps Intel from the standpoint of they've been, they have a large capex bill every year to continue operations, so they need the cash in that respect and can use the investment. And the things that are coming out of this deal, cooperation in both data center products and PC products, is pretty interesting. To take what are really, these are two companies that they compete directly in a couple places, but they're kind of somewhat complementary. I mean, Intel's mainly CPU, of course, and NVIDIA mainly GPU, but Intel wanted to be competing on the AI acceleration front and didn't really work out so well. And so now you have these two companies coming together, historically been competing, and it's looking like you'll have Intel getting integrated more into the NVLink switch, using some of that technology. You'll have NVIDIA built and designed chiplets coming into Intel CPUs on the PC front. And so really it starts to envision things in from a few different angles. It becomes interesting, because from the angle of, if you're AMD, you have two of your biggest competitors coming and joining hands, and that can be intimidating. And if from the standpoint of Intel, if you're within Intel, if you're on maybe the in-house GPU team, the YARC team, you see this and you think, wow, this is interesting. And so Intel has talked about their continuing with their in-house GPUs. This is just to complement the product offering, but I mean, it's naturally going to be
right?
Competing.
Yeah, that's a good point. Before moving in, let's talk a little bit about NVLink. And so this is a link between the GPU and CPU, most notably that the NVIDIA using NVLink to connect between NVIDIA's own GPU and NVIDIA's own ARM-based CPU. Am I understanding this correctly?
Yeah, exactly. So it connects GPU to GPU in many of the placements we've seen today that are like large AI racks where you have 8 NVIDIA GPUs on them. Those are all connected through NVLink typically. And then on the Grace Hopper, the NVLink is being used between the Grace, ARM-based Grace, and the sounds like in the announcements is that Intel and NVIDIA would start designing these systems to where NVLink is linking to the x86 CPUs, which is the Grace Hopper systems are more of a scale up kind of a system, and the x86 based ones are more for scale out. And this allows the NVLink to be further part of take a bigger role in that scale out implementation. Which, and another interesting piece of this is that we're learning more about specialization of the different phases of AI. The tokens in versus tokens out, depending on the size of those tasks, it can make more sense to split the AI function into 2 different pieces or more pieces. And what you can have is it may be that one set of hardware is better tailored for this input phase, whereas a different set of hardware is better tailored for the output phase. And if that's the case, then you could see that this NVLink, this move allows them to use x86 on a piece of that, and then use ARM on another piece of that, and then have it all working well within a single rack or a single server. It could be interesting.
So what you're saying is that, if I understand it correctly, rather than having someone come in, like there are a lot of AI startups out there, and do the custom chips for custom tasks by adding x86 and ARM in the mix. And of course, as you said, NVIDIA being the king of AI. So it sort of like creates or broadens the options to proceed with various tasks that AI would like to run. Is that right? Or
Yeah, exactly. Yeah, I think what this could lead to, and some of this is more just our own hypothesis is here, but this is what this can lead to is a further move towards heterogeneous compute in as it pertains to the AI workloads, and to various ways for that to play out. Whether it makes sense to mix and match between x86 and ARM in the same system, that's yet to be seen. But I think there's what we're seeing on that front of breaking up, as I mentioned, breaking up the AI into the smaller pieces for turning the whole crank on. I mean, to take the full inference load is not just one task; it's several tasks in a chain. And if some of that's better suited for one architecture and the other piece is better suited for another, well, they should be in the same rack or in the same data center for sure. And the best way to link those, as we've seen, is through NVLink is the top of the line.
Interesting. But there is other competing link, right? What is called UA link?
Yeah, so that's where that gets tricky for some of the other players in the industry. So now, I mean, and Intel's party to the UA-Link consortium, and so that's an open source way to interface different components within a data center, and that's where something like CXL was heading towards that direction too. And CXL is another way to interconnect GPU to GPU. It's just if you were a data center operator and you wanted the fastest, the best connection between your hardware, between your accelerators at least, you had to go with NVIDIA, and this allows that's still the calculation, but now it opens up to if you also want to link it to your x86 based CPUs, as long as you're going with the Intel custom NVIDIA option.
Right. Let's zoom out the lens a little bit. Take a look at what's going on in data centers. Actually, all those hyperscalers are building their own AI chips, right? So in that context, I mean, the world is still, well, we can still say that the NVIDIA is the king of the AI, but at the same time, when you look at the bigger picture of data centers, I mean, all those hyperscalers making their own chips. What this deal between NVIDIA and Intel, would that change the picture?
So it can. I mean, the custom silicon that we've been seeing AIA6 for, I mean, the biggest names out there like Google TPU or Amazon or AWS Inferentia Trainium, these and Meta has projects too. Those projects have started and they're already at various levels of maturity. I mean, TPUs on version 6, I believe.
Yeah.
So those are fairly mature, but what this does, it takes other hyperscalers or other smaller players that have been heading down this path of designing their own silicon for their own more tailored workloads, and says, oh, okay, well, here's another way to customize somewhat with using off-the-shelf hardware. Part of the push towards this, the build versus buy decision that the hyperscalers have been making is, as we see it, one would only want to pay NVIDIA margins for so long before figuring out how to do something similar in-house. That doesn't really change. I don't think that's going to change the picture with this agreement.
Yeah,
I expect those margins will still be strong.
Still high.
Right. Yeah. But at least it also raises the bar for what your in-house solution is going to have to compete with from a performance standpoint.
I'm just curious, I'm a total amateur here, but how long would it take companies like Intel to embrace NVLink and work with NVIDIA? I understand NVIDIA typically works very fast, but how long do you envision NVIDIA, Intel integrated products to come to the market?
Honestly, I don't know what
You
that's.
don't know.
No. I mean, I would expect to
Yeah.
see something later next year, but the roadmaps of NVIDIA, have us expecting Vera and these kinds of things into next year. I don't think that this would intercept that, but maybe 2027 potentially. But I mean, I
Yeah,
could
we
be.
don't know. We don't know.
They
Yeah.
could have been talking for a long time before this
Yeah.
announcement came out. So
Yeah, no, that's true. So, tell me that the first time people heard this news, the first instinct everybody had, like a reporter like myself, oh, this is the good news for Intel's foundry business. How does this translate, to the Intel's struggling foundry business? You think, even though that wasn't
yeah,
explicitly mentioned in the press release?
I mean, it indirectly provides some cash for investment in the foundry business. I don't. Nothing about the announcement and what we've heard subsequently tells us that this will move more orders into the foundry, other than that, at least if it boosts Intel's CPU share, then at least that's going to move more silicon through Intel. The NVIDIA pieces of this are still TSMC based, and they would continue to be so for the foreseeable future, as far as we're concerned. I mean, that's where NVIDIA has become so successful on the backs of TSMC's front end processing as well as their back end processing, and perhaps that's where this can start to become interesting, is becoming more
Packaging.
right.
Yeah.
So NVIDIA's gone with the CoWoS on all of these accelerators, different flavors of CoWoS from TSMC, and I would expect that to still continue on these data center systems, because that CoWoS is what interconnects the HBM to the accelerator. But the piece that gets interesting is on the PC side of this, where they would be attaching a small NVIDIA GPU chiplet with an Intel CPU chiplet. That's going to happen on Intel Foveros or
Right.
EMIB technologies,
Yeah.
which could so then you have a multi-vendor. So we've seen a little bit of this already, but this moves us further in the direction of having multi-vendor chiplets into a single package. And if that proves successful, and some of the business implications are figured out well in that, then you'll have more just learning around that. I mean, still just two vendors working together is different than having an open chiplet ecosystem, of course, but it does start to move in that direction. That can be interesting.
Yeah, a step in the right direction. All right. Now, lastly, and there has been some reports about Intel might have had discussions with Apple. This is more of a foundry business side, and I think the key here is the Intel wants to have as many customers as possible for the foundry business. I guess if I'm Lip Butan, which I'm not, but I'd play every card that I could find to get into my foundry business. Do you think this talk with Apple is real, and something similar? It's like a Intel NVIDIA relationship, not on foundry but on the product side, that might have some impact of the potential relationship between Intel and Apple in the future.
Yeah. So again, it's hard to tell what is posturing versus what is more real. But certainly in this environment, there's incentives to. I mean, certainly a company like Apple, an American company like Apple, is incentivized to bring as much in country as possible. They can do that with TSMC in Arizona, of course, but I imagine they have more. They would have more incentive to move that to a U.S.-based company as well, like Intel. The question is as simple as a bargaining play to get better pricing from TSMC, or it can be more serious than that, of course. So far, to our perspective, it seems it could be somewhat risky to take what has been a multi-decade,
hugely successful,
successful roadmap with your main silicon provider, and switch. Here we are at this critical point in time where we're integrating gate-all-around. Of course, maybe there's issues with gate-all-around that we don't know about, but
right.
At the same time, it seems to me it would be risky to make that kind of a switch right now, given the track record of TSMC.
Yeah, no, that's very true. All right, so the upshot is that Intel NVIDIA deal, the announcement is actually a pretty big deal in terms of both data centers and PCs, in your opinion, and that kind of expands the dimension that the Intel can play.
Yeah, absolutely. And if you're AMD, you see your two of your biggest competitors teaming up. That's can be troublesome. Or if you're ARM, perhaps this can push a little bit more towards x86 than towards Grace than what was originally thought too.
Yeah, that's a good point. Yeah, that's interesting. Yeah. But then SoftBank invested in Intel, right?
They're everywhere.
There's a very weird relationship going on, but that's good. Well, thanks for your insights, and we'll talk soon, John.
It's a pleasure, Junko.
All right. Bye.
Take care. Bye.